So you are writing the identities, okay? So there are reciprocal identity. This you are to memorize it. Cosecant theta. So sine theta is 1 over cosecant theta. And don't forget to write theta. Secant theta is 1 over cosine theta. Cosine theta is 1 over secant theta. Cotangent theta is 1 over tangent theta. So tangent theta is 1 over cotangent theta. These are reciprocal identity. And now there are two quotient identity because there's a tangent and cotangent. So tangent theta equals to sine theta over cosine theta. Cotangent theta is cosine theta over sine theta. I'm expecting you to know all this. Sine square theta plus cosine square theta equals 1. Now, I've seen some student writing it this way. This is wrong notation, which is not the same as a sine square theta. So sine theta square means sine of theta square. So it's a sine of theta times theta, which is not what you meant. And when it comes to sine square theta, that means it's a sine theta times a sine theta. This one, you write it square over here, not outside of the theta. So don't forget that. And so that notation, you have to be careful about that one. I'm going to erase this. I've seen only one student doing that. So hopefully you're not the one. And now 1 plus tangent square theta equals to secant square theta. And then 1 plus cotangent square theta equals cosecant square theta. So these are three Pythagorean identity. And so I'm expecting you to know at least this in your head. Now, I'm going to solve the right triangle first. How do you find the R? Can you tell me how you find the R if I give you this information? So go ahead, write it down. So you wrote it, I hope you wrote it the same as what I wrote. 31.56 degree is opposite over hypotenuse, which is R. So then I went into earlier example. R is not equal to 12 times the sine. It's a 12 divided by sine 31.56 degree. Now go ahead, enter in your calculator and give me the answer. Give me the answer. Make sure your mode is in the degree mode. Okay, so you checked your mode, right? So mode should be not the radian and degree. And so enter, and then I'm going to second quote. And I have 12 divided by sine 31.56 degree. And so you don't have to write degree. We are in degree mode, so calculator will not write the degree unit, but you should write it. And so 22.92. So 22.927 approximately, that's a centimeter. And don't forget to write the unit. Is it okay? Now, if I put a similar question, and I'll let you do that question, okay? So I'm erasing this question as my second example, and I'm going to skip out the theta. So I'm going to write this one as a theta, and I'm going to delete this, and I'm going to write this one as say, it's longer, so I'm going to write it, let's say 25 centimeter. How do you find the theta? How do you find the theta if I give you like this? So go ahead, use tangent theta, find the theta for me, and I'm going to wait for you. You all wrote as a tangent theta is equals to opposite over adjacent. And since theta is an acute angle, so you're just going to enter in your calculator inverse tangent function of 12 over 25. But that inverse function give you angle corresponding to 12 over 25. So you go to calculator, and you're going to go to second tangent, which compute the inverse, meaning what is 12 over 25? Corresponding to tangent, what angle correspond to 12 over 25? So it says 25.641 about that degree. So and so make sure you know how to do it. Now I'm going to go to the test review number 24. Now here I'm going to just let's check your answers, and I'm going to work it out. So you need to learn to organize your work. So there is identity. Oh, so okay, so you finish that work for the test, you reorganize it so that you can submit it better work, okay? Okay, so I have one Pythagorean identity which has a sine and cosine both at the same time. This is called the Pythagorean identity. And you know by now, since cosine is given to you, I'm going to find the sine theta by doing this. Sine square theta is equal to 1 minus cosine square theta. Now sine theta itself, since that's a sine square theta, it's a plus or minus square root of 1 minus cosine square theta. Now, since cosine is negative, and tangent is also negative, which quadrant are we on? On which quadrant? When theta is in which quadrant, cosine and tangent both are negative. You know, it's a second quadrant, right? In quadrant 2. In quadrant 2, cosine is negative and tangent is negative. I'm expecting sine theta to be then positive because you're in quadrant 2. So I'm going to drop the negative sign. I'm going to just keep the positive sign. And now it's a square root of, and now I'm going to substitute cosine theta by given number, negative 5/3. So it says 1 minus, and cosine theta is negative 5 over 13. And it says square that, because cosine square is, that means exactly this. So cosine theta is negative 5 over 13. Cosine square theta means cosine theta to the square. So I'm just squaring it. But when you're squaring the negative, it's positive. So we'll have a 1 minus negative 5 to square, that's 25, 13 to square, which is 169. And of course, you're going to change 1 to common denominator, 169 over 169, and do the subtraction. And then 169 take away 25, which is 144. And then all over 169, the common denominator. And so, of course, you can split this one into square root of 144 and square root of 169. And so that's a 12 over 13. And so that's a sine theta. Now I got sine theta and cosine theta is given. So then there is a quotient identity. which says tangent theta is equal to sine theta over cosine theta. And sine theta, we just found it to be 12 over 13. And cosine theta was given to you as a negative 5 over 13. And of course, 1 over 13, 1 over 13, you cancel out. And what's now left is positive divided by negative, so it's a negative 12 over 5. So I got the tangent theta. Now all the rest are reciprocal identity. Cosecant theta is 1 over sine theta. So I just have to invert the fraction of sine. So 12 over 13 get flipped. So it's a 13 over 12. Secant theta is 1 over cosine theta. So I need to flip the negative 5 over 13, which is negative 13 over 5. Now cotangent theta, by the reciprocal identity, 1 over tangent theta. So I need to invert the fraction of this one, which is negative 5 over 12. So these are what I call it, you are getting the tangent trig function using the identity, because I use the Pythagorean identity first here, and then I use the quotient identity, and then I use the reciprocal identity. So here these three are reciprocal identity. And so these are the works I'm expecting you to show me for the question like this. So when the question says use the fundamental identity, you have to use it, because I'm not checking whether you can get the answer with any method. I'm checking whether you know how to use identities. So for this question, yes, you have to use this method. Okay, hopefully, okay, that makes sense to you. So this is number 20 of a test review. It says a bearing of north 30 degree east. So in that case, you're going to draw the north. So board is not going the north. It says northeast 38 degrees. So you will have to tilt the 38 degree to the east. So board is going that direction. So this one is called 38 degree right here. And so if the boat is over here, I don't know how to draw the boat. Does that look like a boat to you? That boat is going that direction, and that is called north 38 degree east. Is it okay? And then change its course. And so the first time the boat traveled 30 miles. So at this time, it traveled 30 miles. And then after that, changed the course and then went into northeast so northeast. So again, so just 1 second, I need to move these drawings a little bit downward. At this time, after 30 miles traveling, change the course now to north 58 degree east. So I need to start changing the course at this time. So that's my direct north, but I'm not going north. I'm going to north 58 degree east. So that's north again, but I'm going to tilt it now this time 58 degree right here to the east. So we are doing this is this direction, and now boat is going that direction. So that's 58 degree east. So now boat is after this one. Boat is over here now. And there he traveled, boat traveled 45 miles. And now, how far north and how far east? So how far north and how far east? So this distance right here, this distance from here to here is total east. And then how far north is this distance? Let me make it a different color. Sorry. Let me make it a different color over here. This is a north distance, and we have to have this one as a 90 degree over here. 90 degree. And now, so in fact, I need to draw the two right triangle. One over here. One over here. And then another one is over here. Make it a little shorter. So I have two right triangles, this one and this one. So this one is a total east direction that the boat traveled, the distance east direction. And this distance right here is a total north distance. So now, any idea how I'm going to get this total? How far east the boat traveled is the horizontal purple line, length of that. How far total north direction the boat traveled is the length of the green line. And how do I do this? Do you have any idea? Do you want to try first? I wait. So you see x1 is the opposite of 38 degrees. So x is the opposite of 38. X1 is opposite of 38. So when it comes to x1 should be equal to hypotenuse, which is 30, hypotenuse times the sine 38 degree. Now x2 is the opposite of 58 degree, opposite of 58 degree. So that means the hypotenuse times the sine 58 degree is x2. So hypotenuse is 45. So 45 is hypotenuse, and then angle is opposite. Angle opposite to x2 is 58 degrees. So it's a sine 58 degree. That's x2. I need to add them together to get that. Now let's go to y2, y1 and y2. Here y1 is adjacent to 38 and hypotenuse 30. So when it comes to adjacent, you have to use cosine. So it's a y1 is 30 times the cosine 38 degree. And now y2 is adjacent to 58 degrees. So y2 is hypotenuse times the cosine 58 degree of your second triangles right here. Now, once you have that, you just have to enter in your calculator and give me the approximation of the distance. So 30 times sine 38 plus 45 times sine 58. And I got on my calculator about 53.57. If you want to approximate that to the whole number, it's about 54 miles. And that's a total east distance the boat traveled. And then total north distance boat traveled is about 34 miles. Oh, so I was in the wrong mode. So let me do that again. So this one is wrong. So I'm guessing this is wrong too because I entered it in the wrong calculator mode. So let me do that again. So now I need to go change it to degree mode. And so enter. So sine, what did you get? Sine 30, sine 38 plus 45 sine 58. I got 56. This one is about 50. I'm going to approximate that, okay? 56.632. So I'm going to go about 57 miles. And now this one, I have to change it to cosine. I have to change it to cosine. And now my mode is correct. So this one is 47.48. So I'm going to approximate to about 47 miles. Oh, thank you, Julius. Okay, so if you look at this triangle over here, and so if you look at this triangle over here, see opposite of 58 is x2. So sine 58 degree, sine 58 degree is opposite over the hypotenuse, right? So it doesn't matter whether which angle, wherever it is, you have to always think it as what's opposite to the angle, and that's going to be your sine. What is adjacent to the angle, which is a y2. So cosine 58 degree is adjacent over hypotenuse. So even if I turn the triangle in opposite direction, you have to know what is opposite, what is adjacent. Do you understand what I mean? So if I draw the triangle right here, like that, and this is hypotenuse, and this is depending on where the theta is. If theta is over here, this is an opposite, and this is an adjacent. So if theta is over here, sine theta is opposite over hypotenuse. And then cosine theta is adjacent over hypotenuse. Of course, if I change the theta to over here, then that's a different story. But you have to think about it, what's opposite, what's adjacent to the angle when it comes to your right triangle. So you could have a different angle opposite to different sides. So if you want to pay attention to that, you know which one is a sine, which one is cosine. So since I used the 58 over here, this opposite x2 is actually the rotated vertical leg. So that's opposite x2 over hypotenuse is a sine 58. Adjacent is y2. So cosine 58 is y2 over 45. That's why I use this. So is it clear things up a little bit? So A and B are running east-west lines. So it's a straight line. A is here and a B is here. Now, station A detects the plane C with a bearing of 61 degrees. So bearing start from the north. And then you always turn clockwise 61 degree. So clockwise 61 degree from the north. So if you turn 61 degree from the north and airplane C is over here. Now bearing of C from the B is north, and it's a 331 degree. So that means starting from the north, you need to turn 331 degrees. So 270 plus 61 degree, and that is over here. And that is 331 degree, and that's short 229 degrees short from 360 degree. So as you can see, this angle right here should be, since AB is a horizontal line, and this angle right here is a complementary to 29. So it's a 90 minus 29, which is 61 degree. Since this one is 61 degree, that one is 61 degree, and this north line to AB is a 90 degree. This angle right here is 29 degree. Now 29 plus 61 is a 90 degree, which makes the angle C a right angle 90 degree over here. And since A to B is 3.7 kilometers, and we are looking for AC, which is my X. And whichever angle you want to use, if you're using an angle 29, you have to use a cosine. If you're using angle 61, you have to use a sine. Hopefully that makes sense to you. So which one did you use? Sine or cosine? Did you use a sine? Did you use a 61 degree? So sine 61 degree is opposite, which is the length you're looking for, over hypotenuse. 3.7 is opposite to 90 degrees, so that's your hypotenuse. So that means x is equal to 3.7 times sine 61 degree. And hopefully you put this in the calculator and get the answer. And I got about 3.236 kilometers. So that's serving as a AC. So this is number 21 of the test review. So you're looking for angle B, and cotangent is positive either quadrant 1 or 3. But see, cotangent is given to you, but your calculator is built-in function is only the tangent function. So you're going to find the tangent B first, which is 1 over cotangent B. And cotangent B is given to you, so it's 1 over. And now replace the cotangent B whole thing by given value 6.78. So what we have is a tangent B is equal to 1 over 6.78. Now the angle B itself will be tangent inverse that. Now this one, go ahead and put it in the calculator. Tangent inverse of 1 over 6.78. And it is giving me 8.39 about. And that's the angle in the quadrant 1. But of course, if you are drawing the right triangle, that's going to serve as a reference angle. And so we have twice tangent is positive. So the first angle you just found is 8.39. The first one you found is 8.39. So that's when B and reference angle are the same. This is going to serve as a reference angle, 8.39 degree. That's the first one. But another angle is this one, 180 plus the B prime, this one, the third quadrant one, that's another one. So what is the second B value? How do you find that? That's just 180 plus the reference angle. Remember, this is reference angle, which is equal to B itself in quadrant 1. And there's another value B in quadrant 3 because tangent is positive in quadrant 3. So that one is 180 plus the reference angle. So you know you have two answers. This one. So we just have to add 180 to that. So I can just write it as 188.39 as my second number. So we have two answers. This one, quadrant 1, and this one, quadrant 3. There are the number angle between 0 and 360 degrees. So there are two answers for this one.